Our next example is going to demonstrate memory segment displacement addressing mode. Let's start with an example like this. For instance, we can have an integer named temp1, and this will be double word, and I'll set it equal to 1. And the second integer also double word, and the value is 2. Then I can set EDX register equal to the value of temp1. So this way, we basically what we do, we assign EDX equals this value temp1, which is 1, right? So it will be using this label inside our data segment, and will retrieve value 1 from memory stored as integer and set it equal in EDX. So we can just write pseudocode like this. And in this slide, the displacement is shown just by its name, but I always prefer to use square brackets, because displacement means memory displacement, memory base segment displacement, or offset, and in this sense, it's just much easier to use square brackets. Although it's possible to write code like this, I prefer to use square brackets to make sure that we're pretty clear that this is something that's pointing, that contains an address of this integer, and we load it into EDX. So the next line will be this instruction right here. So move, actually add, right? So we're going to add to EDX. So EDX is already loaded with 1, and then the next line we're going to add temp2. Okay, so temp2 of course contains value 2, so 1 plus 2. So this is going to give us the result of EDX equals EDX plus temp2. Okay, so we're expecting EDX to be 3. Let's run this real quick in debug mode. So let's build and run this in debug mode. Start debugging one more time. We debugging stops at the breakpoint, and I'll just press F10 a few times to fast forward to this instruction, and let's make visible our registers. Okay, registers, and so these are our registers. So currently register EDX contains this, I suspect this is some sort of value, the address that it contains initially, but we're free to use these registers in our main function the way we need. And so let's execute this next instruction, move into EDX, this value F10. You see that EDX has changed to 1, so obviously this got loaded into register EDX, and next instruction is add F10, and here we go, we have 1 plus 2 is 3. So this works, but again we're mostly focusing on the encoding and the instruction format. And so let's take a look at the disassembly. So these two instructions, move EDX and add EDX with these two places. So officially this type of addressing is called displacement, memory displacement. It's really the displacement in memory segment, in our global memory segment in this case, as we use these instructions. And the format includes this first byte of the instruction format, of course, is the operation code, and the first 6 bits set to 0 indicate that this instruction is an add instruction. Then we have our direction, indicating which one of these is the source and which one of these is the destination. So we have this 3, and then in the next part right here we have encoding 15. Okay, so this is mode RM byte right here. I think that this encoding looks a little different. It's written here as 031D. In my case, this is written as 00315. So let's find out what is the difference between 1D and 15. So let's see. I'm going to open our presentation and use it here as a reference. So in particular we're going to be interested in this table and the next table, which is decodes all sorts of addressing modes. So we have mode reg RM byte indicating 15, hexadecimal 15. So of course if we take our calculator and set basically enter this byte as hexadecimal 15 like this, you see that the encoding, the binary encoding of this byte is 001 and then 0101. So I'm going to copy this and write it somewhere in our source file so that I can, oh, this really didn't copy the value for me. I need to be able to copy it, pressing Ctrl+C and try it again. No, still didn't work, so I'll just manually move it, manually write it down. Okay, so the value should be 001, then 0101. Okay, so then we're going to split this value into two parts. One part will be 00 and 101. Oh, again, I was in the middle of debugging it, so I'm gonna have to stop debugging right now and just finish with this portion. So this will be like this. So this is mode plus RM right here. Two fields combined, right? It's this field, which is the mode field. Okay, and this is the reg field right here, and this is the RM part, like this. And what we're trying to do is understand what this mode reg RM byte is trying to do. And of course the reg field is 010. So let's take a look at 010, and it's indicating EDX. Okay, so this field right here indicating EDX, this, and 00101, 00101, right? So if I resize it, 00101 indicating 32-bit displacement only mode. Okay, so this indicating displacement only mode, which if I build this to make sure that we need to add a comment here and build, and run this code. Okay, and take a look at our disassembly view, and if I resize and move this to the next, So what this really indicates, this byte 15 in this encoding of our instruction, it's indicating that EDX is going to be used as a destination because of this, right? So this indicates, one quick look at this, it's indicating that, of course, register EDX is going to be the destination of this instruction. Why? Because the other operand is the memory operand, and this is the second operand, is our displacement, and it's stored in little Indian format, which means stored backwards. So its interpretation should be 0056, okay, 30 and 50. Actually, 05. So anyway, so this, it's right here spelled out, 563005. So this will be the address of our operand, which we're trying to retrieve, this address. And the idea behind displacement only is simply that, as shown on this slide, what we have is operation code. We have mode RM indicating this special type of displacement only mode, which is direct addressing access into memory, a specific location in memory, like we have right here, right? So this is our memory that we're trying to access in this instruction. And what follows it is the displacement. And right here, if we switch again to the disassembly, this is our displacement. So this red 32-bit displacement is right here. Okay, so this is an encoding of this instruction, and I suspect that I simply have a typo right here. It should not be saying 1D. This should be saying 15. This is why I went back to all of our tables and verified that this is indeed matching the mode that we really trying to achieve here. Basically, displacement only mode is like this. You just have an address, and you know what that address is, and you specifying it directly, and the instruction will remember this address. But the data segment itself will be located somewhere in computer memory. So this label, of course, is just an offset from the beginning of the global data segment to the location of this integer. So that's why everything here is done relative to the beginning of our data segment. So it's really a very simple idea. It's not very complicated. The objective of our presentation in this video is to be able to visualize all of these bits and make sure that we can explain the structure of all of the encodings that are generated for us by the assembler. So you should also see that because the format of both of the move instruction and add instruction are quite similar, right? So right here, they obviously fall into the same category, and you can see that it's the same type of mode RM byte that's used by both of these instructions, move and add. But of course, the opcode of move becomes 8B, which is a different opcode. It indicates this instruction, and add instruction has zeros.